Well, in this video, we're going to graph a couple of rational functions, and I want to just make a point that if you forgot all of the little tools that we have that we've learned so far, you could simply plot, 20 or 30 xy pairs, make a table of 20 or 30 xy value pairs, and you'd get a nice feel for exactly what the graph looks like. But if you draw the asymptotes, you'll find that you only need to draw maybe 3 points on either side of the vertical asymptote, and you know what the shape of the graph is. So let's proceed with f of x equals negative x over x plus 1, and I've kind of given us some helpful hints here on the left. Okay, the first thing says determine the y-intercept, if any, by finding f of 0. But f of 0 would simply be a 0 over 1, which is 0. So that gives us the origin as 1 point. All right, how do we find the x-intercepts? Well, we set f of x equal to 0. And the only way this can be equal to 0 is when the numerator is equal to 0. So, well, it turns out this didn't help us because the x-intercept happens to be the y-intercept as well. Okay, so we have 1 point so far. Now let's find the vertical asymptotes. Remember how to do that? We set the denominator equal to 0. And whatever that solution is, each one of the solutions is going to give us a vertical asymptote. And there's only one solution to x plus 1 equals 0. The vertical asymptote is going to be x equals negative 1. All right, so x equals negative 1, a vertical line just like that. I use a dotted. It's not really part of the graph, but it just helps us to graph the function. Now let's look for the horizontal asymptote by examining n and m. Remember what they are? N is the degree of the numerator, m is the degree of the denominator. Well, in this case, they're both x to the 1 power. So n is equal to m. They're equal. So how do we obtain our horizontal asymptote? We look at the coefficients of these leading terms. Negative 1, positive 1. Negative 1 over 1 is negative 1. So horizontal asymptote y equals negative 1. All right, let's go ahead and plot that. Y is a negative 1. Horizontal line. Okay, let's plot a few more points and we'll graph it. So we already have 1 point plotted, the origin. Let's pick 2 more points to the right of this vertical asymptote at negative 1. I want to pick one that's in between here. So let's say maybe negative 1/2. And it'll probably be up here somewhere. F of negative 1/2. Maybe I'm running out of room down there. I want to make sure I have enough. F of negative 1. I'm sorry, f of negative, the function isn't defined at negative 1. So I'm going to say at negative 1/2. F of negative 1/2 is going to give us a positive 1/2 upstairs. And then negative 1/2 plus 1 is 1/2. So we get positive 1/2, so that's going to be negative 1/2, comma 1. So negative 1/2, comma 1. So right here I'm going to go up to 1. Just as I expected. And if we even got closer to negative 1, it would be blown up way high up here. And then let's plug in something like maybe 1, 2, 3, 4, 5, 6. Let's do f of 6. That would be negative 6 over 7. Negative 6 over 7. So that's almost negative 1. So the ordered pair would be 6 comma negative 6 over 7. 1, 2, 3, 4, 5, 6. Almost down to negative 1, not quite. So I'm going to go ahead and graph that, just with those 3 points. It's going to look similar to previous graphs. It's going to look like that. All right, so now let's do 3 points to the left of this vertical asymptote. So how about negative 2 for starters? F of negative 2 is going to be positive 2 over negative 1. 2 over negative 1 is negative 2. So the ordered pair is negative 2, negative 2. So negative 2, negative 2. Okay, we've plotted that point. Now let's continue with maybe something like, negative 6. F of negative 6, which will be a 6 on top, over negative 6 plus 1 is negative 5. Okay, negative f of negative 6, so the ordered pair would be negative 6 and then negative 6/5. So 6/5 is a little bit more than 1. So negative 6, 1, 2, 3, 4, 5, 6, a little below negative 1 puts us right about there. Okay, and we'll do one more point in between negative 1 and negative 2. Negative 1.5 would be negative 3/2. So f of negative 3 over 2 is going to be on top a positive 3 over 2. On the bottom, it's going to be negative 3 over 2, negative 1.5, plus 1, which is negative 1/2. And that's equal to, the 2's cancel. 3 over negative 1 is negative 3. So the ordered pair is negative 3 over 2, comma 3. Negative 3 over 2, 1.5, comma, I think it's going to be a negative 3, yeah. Negative 3 puts us right about there. Kind of like we expected. So the graph's going to look like this. Okay, we've seen a graph that looks something like that before. And maybe I'll just circle all of the ordered pairs that we graphed. And then the origin was up there. And one more up here. So 1, 2, 3, 4, 5, 6. Yeah, we plotted 6 points. Okay, let's now look at the second example, the last example of this video. 3x over x minus 2 is what the rational function is. Okay, so determine the y-intercept by finding f of 0, which is 0. So we get the origin. Set the denominator equal to, to find the x-intercepts, we set f of x equal to 0. So we're setting 3x over x minus 2 equal to 0, which means that the numerator has to be 0. 3x equaling 0 means x is 0. So we gained nothing. It's that same point. So this point is the only x-intercept and it's the only y-intercept. To find the vertical asymptotes, we set the denominator equal to 0, which means our only vertical asymptote is x equals 2. X equal 2 will be this vertical line. And now we find the horizontal asymptote. Well, it's similar to the last one in that the exponents, the degree of the top and bottom, are both 1. So they're the same. So the horizontal asymptote will be y equal, now let me go ahead and say n is equal to 3, m is equal to 1. So y equals 3 over 1 is the horizontal asymptote. So y equals 3. 1, 2, 3. Horizontal line. All right, now let's plot some points. Well, we already have 1 to the left of this vertical asymptote, so let's just find maybe 2 more. If I go to the left maybe to 6 or 8, I'll go x equals negative 8. I expect it to be somewhere in this region. F of negative 8 is going to be negative 24 over negative 8 minus 2 is negative 10. And that's equal to positive 2.4. I'll use a decimal this time. So we get negative 8 comma 2.4. 1, 2, 3, 4, 5, 6, 7, 8. And if we go up 2.4, that's about right there. That's about what we expected. And then if I plug in a 1, I expect it to be somewhere down in this region here. So let's plug in a 1. F of 1 is 3 on top over 1 minus 2, negative 1, which is negative 3. So that gives us 1 comma negative 3. 1 comma 1, 2, negative 3, as we suspected. So I'm going to go ahead and draw a smooth curve through these 3 points, and we know the asymptotes, they eventually get very close to, the curve gets very close to those asymptotes. All right, like that. And now to finish this, let's do 3 points to the right of this vertical asymptote. So x value is greater than 2. So how about 1, 2, 3, f of 3. F of 3 is going to be 3 times 3 is 9 over 3 minus 2 is 1, 3 comma 9. 3 comma 9. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and let's do maybe a 5 and 8. F of 5 is 15 over 5 minus 2, 15 over 3. So that gives us 5 comma 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now let's go all the way to 10. How about that? F of 10. When x is a 10, we get 30 on top, 3x, and then 10 minus 2 is 8. That is equal to 15 over 4, which is almost 4. But it's 3 and, let's see, be 24, 3 and 6/8, 3 and 3/4. So 10 comma 3 and 3/4. 10, 1, 2, 3, there's a little ways above 3. So this looks like the graph will be something like this. Okay, 2 examples that were actually very similar, and we've got, I believe, one more video where we do just a couple more examples to finish up this section.